Here is installment number 5 of Logarithms in a nutshell. At the end of the previous episode, I promised you that I would discuss decibels and the way that we perceive sound and light and radio signals in terms of the logarithm of the intensity rather than directly according to the intensity. And then I remembered that there's one more general rule about logarithms that you should know. The logarithm of x to the y power equals y times the logarithm of x. Now in this particular formula, x must be a positive real number. It cannot be 0 and it cannot be negative. However, y can be any real number, because if we raise a positive real number to any real number power, we will always get another positive number. So we don't violate the dictum here where we can't have the logarithm of anything negative and we can't have the logarithm of 0. Let's just work out a little example of this. The logarithm, let's say of OG 10 squared. The logarithm of 10 squared. Okay. The logarithm of 10 squared, of course 10 squared is 100. We know that right off. And the logarithm of 100 is 2. Because 10 squared equals 100. So the logarithm of 10 squared equals the logarithm of 100 equals 2. Well, okay, according to the formula I just gave you, this is equal to 2 times the logarithm of 10. Remember, when you see log written all by itself like that, it generally means the base 10. Logarithm, also known as the common logarithm. Okay, fine. Logarithm of 10 squared equals 2 times the log of 10. What is the log of 10? That's 1. Because 10 to the 1 equals 10. So, it works. How about negative 2? Let's just try, well, how about negative 3? The log of 10 to the negative 3. Well, 10 to the negative 3 equals 1/1000th, or 0.001. I usually put a 0 in front of there. Front of the decimal. Logarithm of 0.001. The logarithm of 1/1000th, if you take your calculator and figure it out, you're going to get negative 3. Okay? Well, that's cool. According to the formula, that's going to be equal to negative 3 times the log of 10. Well, once again, the log of 10 is 1, so once again we get negative 3. Well, that's all fine and dandy because we've been using 10 as our base there. But here's one that I invite you to figure out. The logarithm of 2 cubed. Okay, try that one. What you're going to get here, 2 cubed is 8, so that's going to be the logarithm of 8. When I take my handy dandy calculator, I'm just going over here and I'm just going to do this one. The logarithm of 8 is 0.903. Let's put that down in our little memory bank. 0.903. Store it in memory. Okay? Well, this is also going to be equal to 3 times the logarithm of 2, according to our formula there, which equals 3 times. Now I go back over to my handy-dandy calculator and take the logarithm of 2, 0.301. Well, I don't think we need a calculator to figure out that 3 times 0.301 equals 0.903. Now I've rounded those off to 3 decimal places, but in fact, these are all irrational numbers. They cannot be expressed in a finite number of digits in decimal form, nor can they be expressed as fractions. You've doubtless had some exposure with irrational numbers, such as e, pi, the square root of 2, and the logarithm of 2, and the logarithms of most numbers. So, once again, we can write this now in logical form. For all x and for all y, if x is a member of the set of positive real numbers and y is an element of the set of all real numbers, any real number, then the logarithm of x to the y power equals y times the logarithm of x. Remember, we read this again. For all x and for all y, if x is an element of the set of positive real numbers and y is an element of the set of real numbers, then the logarithm of x raised to the y power equals y times the logarithm of x. Stan Gibilisco signing off. Till next time.